In a previous video, I introduced some adaptations that help deliver hard, crushing bites. This included a wider skull to help support larger muscles, a deeper skull for bone reinforcement, which helps disperse the stresses that go through the skull during biting, and also a shorter face, which can increase the leverage, which means you essentially get more muscle force converted to bite force. But you know what? In the chats I've had since making that video, something's come up a few times. What about crocodiles, Rex? Crocodiles bite pretty hard, don't they? Nothing escapes those jaws. So why don't crocodiles have short faces? So I decided to do a video about it.
Yes!
So prepare to discover why crocodiles need longer faces, the mechanics of how a longer jaw can snap shut faster than a shorter jaw, and the price these animals have to pay to keep a longer face while still delivering those crushing bites. Dr. Rex here, welcome to the Scullywag Lab, where I present the bare bones fundamentals of skull science. Now, crocodiles have a pretty unique way of hunting that isn't really seen anywhere else. Animals sometimes weighing hundreds of kilos can be snatched away in the blink of an eye with one super hard bite. And of course, this unique mode of prey capture should be expected to have an equally unique skull to do the job. But do these hard biters really not follow the same rules of adaptation as other hard biters? It turns out they actually do, but with one key difference, and they literally have to pay a pound of flesh to get away with it. Let me explain. A longer face doesn't just decrease bite force, it can also increase how much muscle and bone is needed to bite hard. For starters, increasing the length of the face means converting less muscle force to bite force. This means more muscle is needed to generate those high bite forces. But also, with greater muscle forces being applied to the skull, there's more force dispersed throughout the structure during biting. More force dispersing through the bone means more bending of the bone. This can be dangerous for the animal because too much bending can lead to breakage. In response to this, more bone is needed to reinforce the structure. So for a longer face to bite hard, there would need to be more muscle to generate greater force and more bone to disperse the stresses. Why is this an issue? Because muscle and bone are heavy and muscle and bone are expensive. Building these tissues can require loads of proteins and minerals in their construction. These are resources that could be better applied somewhere else. Crocs need all this muscle and bone to hold on to prey that can get pretty huge. But this isn't the case for all crocodilians. Some like to stick to smaller prey. For a nice contrast, let's look at a similar skull to a crocodile's that doesn't need to bite hard. The gharial. It has the same kind of overall skull shape that's recognizable as croc-like, but much less bone reinforcement and smaller jaw muscles, because this species only needs to catch small aquatic prey like fish, frogs, and crustaceans, usually while still in the water too. Now looking at the saltwater croc skull, you can see they've maxed out on their bone reinforcement. This salty skull's basically a solid plank of bone, so it can be able to handle the huge forces that travel between the jaw joints and the biting teeth. These forces come with equally huge jaw muscles. Look at the spaces available here for adductor muscles. It's just crazy. So why do crocs allocate so much of their metabolic resources to maintaining all of this muscle and bone? Wouldn't it be easier just to, I don't know, have a shorter face? Well, we need to think about how their hunting strategies might benefit from having a longer face, and why this might be more important than increasing leverage with a shorter face, and therefore allow them to save on resources. Crocodiles are ambush predators that rely on powerful bites to capture and subdue their prey. They need to be able to do this with pretty much any animal that comes within their range. These can get really big and difficult to control. Now, at first you might think, well, in that case, a longer face is just better for reaching further out of the water and grabbing the prey. Or you might be thinking that longer jaws can also offer a wider overall gape for the same gape angle. And you'd be right, those are certainly advantages. But there's something perhaps more important that comes from a longer face. To capture prey in that first lunge, they need to be fast. Really fast. Because crocs only usually get one shot or one opportunity to seize everything they ever wanted. They want to capture it. They don't want to let it slip. Anyway, the point is they need jaws that close hard and that close fast. And it turns out longer jaws can close faster with less effort than shorter jaws. This all comes down to rotational velocities. Imagine a joint that turns at a constant speed, and this would be regardless of the distance we're talking from the joint to the biting tooth. Well, the distance travelled along an arc around that joint increases with an increase in the distance from the joint. In the case of the jaw, the radius is the distance from the jaw joint to the biting teeth. Velocity equals distance over time. Assuming two sets of animals close jaws at similar speeds, longer jaws will move at a faster pace than shorter jaws. The analogy I like to use for this is shining a torch at night. I'm sure most of you would have used a torch before, but have you noticed how it takes the same amount of time and effort to shine a torch across 5 bricks on a wall that's really close by as it does to shine a torch across several trees further away? The torch might be rotating in your wrist at a similar speed, but the contact of the beam travels much faster across things that are further away, so that's why longer jaws can close faster. A crocodile relies so much on the enhanced reach and jaw closure speeds gained from a longer face that it can't shorten its face to improve leverage, and it has to go all in on the muscle and bone to compensate. This gives them the best chance at securing whatever prey comes down to their shorelines. So this all begs a question. Was there ever a species of crocodilian that did not have this need to have a longer face to latch onto prey the way all crocodilians that are around today do? And if it was freed from this need to snatch prey with a longer face, was it able to evolve a shorter face? Yes. It turns out there used to be heaps of crocodile relatives that lived nothing like crocs today. They roamed around on the land. Some even might have galloped like horses. And among these, there was a species called Simusuchus, also known as the Pug Croc. This guy had a much shorter face than crocs around today. It also had really weird teeth shaped like leaves. It's thought to have fed mostly on vegetation. So there you go. In summary, crocodiles do have skulls that are adapted for hard biting, they've just taken the more difficult route to do it. Maintaining all this muscle and bone is expensive, which is why other animals don't tend to evolve similar shaped heads for biting hard. Overall adaptation of the skull is all about optimizing solutions to competing problems. Clearly for crocodiles, the need to snap their jaws shut fast is more important than shortening their face and saving of resources. And I guess this reflects the overall relative importance of selective pressures that have shaped their hunting strategies over millions of years. Catch you in the next video.